So remember the previous arrangement of the ideal gas law, we were able to calculate or determine how we could use the ideal gas law to calculate the density of a gas, of an ideal gas, given the other parameters. So now we're going to calculate, if we don't know what the identity of an ideal gas is, can we calculate its molar mass and then possibly determine what that gas might be? Not knowing its identity. And we have to remember, before I had this expression here where I talked about how you calculate the number of moles from grams, and we said when we're calculating moles, it's mass divided by molar mass. That's going to be our first step here in our substitution. Pressure times volume equals mass over the molar mass times RT. Now this particular rearrangement is a little bit more straightforward, and the reason for that is that before we're trying to calculate mass over volume. Here we just want to rearrange it for molar mass. So what we're going to do first is the same step that we did first in the last problem. We're going to multiply both sides by molar mass. So the molar mass crosses out on the right, and we end up with molar mass on the left-hand side. Right? So if I write that out, I get pressure times volume times the molar mass is equal to the mass of the gas times R times T. Good so far. We want to get molar mass all by itself, so we're going to divide both sides by pressure times volume. When we do that, pressure times volume crosses out. We're left with molar mass all by itself on the left-hand side of the equal sign. And so we find that the molar mass of whatever ideal gas we're dealing with is just the mass of that ideal gas times R times T over pressure times volume. And so you'll notice that if we know what mass of an ideal gas we have in a container, and we know the temperature at which that gas is at, and we know the volume of that container, and we know the pressure of the gas inside that container, then we can calculate the molar mass, which may help us determine what the identity is. So it's another useful parameter that we can calculate using the ideal gas law.